All right, this is our second part to our little video thing to get you guys through your post-op. Okay, so hopefully you've done the first part, no problem. So now we're gonna focus on some of the calculations. So what you're gonna do is this thing says for letter D, it says calculate your slope using the hand method, graphing calculator, or Excel. I'm only gonna show you the hand method. If you already know how to use your graphing calculator, or you can jump onto Excel and type it in there to get your slope, that's fine. Just make sure you show what you did, okay? But I'm going to show you how to do it by hand, which I think is honestly a very valuable skill, especially my kiddos going on to physics eventually. You're going to have to know how to do it no matter what. So I would take it in and see if you can get a grasp on it, okay? All right, so what you do when you are trying to calculate your slope is you have to pay attention only to your best fit line. So my best fit line is in green right here. I'm not going to pay attention to my dots. You do not want to use any of your points, okay, unless you absolutely have to. What you kind of want to look for on your graph is anywhere where that best fit line is going right through a corner. So if you can see kind of right here, right along here, it's going right through. So that's a good point for me. So what I'm going to do is I'm going to go ahead and put a circle right here so that I know I'm going to use that point. I'm going to check the line to see if there's any other ones. I see another one up here. Okay, and typically that's what you would do. Can you use the 0, 0? Yes. Okay. I'm not going to, because I do want you to understand that you don't necessarily have to, okay? And sometimes it's not even going to be an option. So I'd rather you be prepared for that than just knowing the easy way, all right? So if you choose to do the 0, 0 for this lab, I will respect that, and that's fine, okay? But I'm going to go ahead and show you now what we're going to do. So you have your 2 points on your line, okay? So you guys can kind of see mine is right there and right here, okay? What you think of here is this is going to be your 1, this is going to be your 2, as in the second one is later on, and the first one is initially. And that's kind of the idea that you get here, because you want to know how is this line progressing, so you can kind of think of it going on in time, okay? So the calculation or the equation that you use for calculating slope is going to be y2 minus y1 all over x2 minus x1. So notice your ordered pairs are vertical, okay, like that. So when we go to fill this in, okay, I am going to go ahead and put a little ordered pair up here so that I know what I'm dealing with. So this one is 5.75 on my x-axis, and on my y-axis I am at 48 exactly. So cool. This one down here I'm at 1.5, and looks like my vertical is 12. Okay, so that was pretty easy. So awesome. Remember, it's listed as x, y. So that's kind of an indicator on how you're going to fill this in. So my slope is going to be equal to my y2, 48, minus my initial y, 12, all divided by my x from the upper one minus my x from the lower one, okay? So you're gonna go ahead and plug those into your calculator. I'm gonna pause the video for a second to do that. Go ahead and get your 2 points and calculate your slope, and we'll meet back up. Okay, so when I calculated mine, I ended up getting 8.47. And how do you know what to do for your units? Well, you put your y-axis over your x-axis. So look at your units. On your y-axis is grams over your x-axis, which was centimeter cubed, okay? And hopefully that's starting to kind of look familiar, something from your summer assignment. Okay, so on your graph, all right, so you might have done your work somewhere else, or you could have, if you had room on your graph, it's totally fine to show some of your work on there, as long as it's not getting too crowded. Otherwise, just use the next side of the page. Show me your calculations so that you get credit for that. But what I do want you to have on your graph is for sure your slope. So you're going to put on there slope equals, and I'm going to go ahead and put mine, 8.47 grams per centimeter cubed. Okay. Our next step is we're going to, let's look at our instructions here. Use our slope-intercept formula and write your equation on your line, on the graph, replacing all of the variables. So what I mean by replacing all the variables is you guys, when you first learn your slope-intercept formula, right, looks something like y equals mx plus b, okay? Well, looking at our graph, we know that the plus b is 0 because our y-intercept, okay, so where it's hitting my y-axis is at 0, my best fit line, okay? So we're going to get rid of that part. But now we're going to replace our y with who our y-axis is. That's going to be mass. So we're going to say mass is equal to, m is your slope, so I'm going to say 8.47 times whoever's on your x-axis, which is volume. This right here is the equation of my line, okay? And so this I would like to move over to the graph, okay? So make sure you put this underneath your slope formula, okay? So I should see both of those items on your graph, okay? All right. The last part is that I'm wanting you to now show that your equation is going to basically prove density, all right? And so you're going to be able to use one of your data points, and you're going to be able to calculate a density. So, for example, if I wanted to do this data point that's down here, my very lower one, okay, I would do my 8.62 divided by 1.5. Where am I getting that from? Well, this is our equation that we just came up with, right? And so I had a mass of 8.62. And it was equal to my slope times my volume, okay? 1.5. And what you're going to see is calculating for this, it probably isn't going to come out right. And we can tell that because it's below our best fit line, okay? But what we're looking at here, what I need you to get from this, and so I'm going to want you to show me at least a couple calculations on this, especially for your oddball medal, okay, is that mass is equal to this relationship between mass and volume, which you guys learned over the summer, hopefully, was density times volume, okay? This is your new formula. This is something that you're going to practice after you're done with this lab. And what that is density is equal to, if we want to manipulate it, okay, we're going to divide the volume over, is equal to mass over volume. And that is exactly what you just did, okay? So you basically said this 8.47 is coming from my mass over volume, which should hold true for most of your points on your graph. That's what we're trying to say. This is the main idea here, okay? So back to your lab journal and what's going to be expected of you. So you now have your slope-intercept formula, okay? We replace all the variables. Everything's on the graph, okay? On the next page, I wanted you to show your equation being used with the data points of one of the metals. So I want you to show this little step on the next page where I just manipulated our equation and turned it into the density formula. And then I want you to try to see if try and use one of your metals that's on the line or very near the line. And you should see it come out to almost that, okay? So I want you to take the mass and divide it by its volume and see if you can get close to what your slope was, okay? So you're going to show me that calculation. So for example, in my lab book, I would have said what I was trying to show you earlier, which is, actually, I'll take one that's actually on it. I'm going to do 35.6. And I'm going to divide it by 4. And I'm going to see that that comes out to be density. And I want you to see how close it is to your slope. Okay, is it close to it or is it really far off? Hopefully it's really close to it. Okay, and it says use the density equation and calculate the density of your 5th metal. What I'm talking about there is your 6th metal, all right? So that oddball metal. So my oddball metal was, let's see here, 74.66 with a mass, and the volume was 6.5. So I'm going to have 6th metal. You can just label it in your calculation section, and you're going to say whatever the mass was divided by the volume, and you're going to go ahead and calculate that. And I got 11.48 for mine, okay? So my mystery metal has a density then of 11.48. So now comes kind of the interesting part where you get to figure out, do you have enough information to know which metal you actually have? So looking down for our post-lab questions. So all of your calculations should be done now. Okay, you've calculated density at least twice. You have your graph, you have your slope-intercept formula, all that stuff. Post-lab questions. So have a clean page or a clean section so you have enough room to write your answers for these. So your post-lab questions start you off by saying, does it make sense that any trend or pattern in the data should include 0, 0 as a point? Explain your reasoning. That one, what I want you to think of is it possible for an object with no volume to have mass? Or is it possible for something to have mass but no volume? Okay, so ponder that for a little bit and go ahead and write your answer for number 1. Number 2, okay, is talking about what kind of trend or pattern is obvious in the data. And I asked you, is it direct or indirect? So a direct relationship is going to be a positive slope or something that goes in the upward direction. An indirect relationship is going to be a negative slope or something that goes in the opposite direction. So looking at your graph, hopefully yours looks like mine, we definitely have the direct, okay? So we have a direct relationship. And what is that relationship between the volume and mass measurements? Well, mass over volume gives us density, okay? Also, as you grow in mass, you grow in volume, or as you grow in volume, you're growing in mass, as long as you have the same substance. That's the definition of your direct relationship here, okay? So as volume goes up, mass goes up for same substance. Oops, for same substance. And that makes sense, right? So if you have like a tiny glass of water versus a huge glass of water, as we increase that volume, that mass of that water is going to get bigger, right? So should make sense there. All right, next question. So we're on number 3. Now we're going to figure out what our metal is. So looking at mine, my slope was 8.47. So I'm going to come over here and I'm going to look at my options, okay? 8.47, I would say, is really, really close to this one and really, really close to this one, okay? It's kind of in between both of those. So now I have to use my observations. What I remember seeing was my metal happened to look like a penny. So I know that I am copper, okay? So my metal was copper, and you're gonna go ahead and label your metal. And then I want you to look at your 6th one and figure out what that one was. So mine was 11.47. So I automatically fall under the lead category. So when you're going to answer number 3, just make it nice and neat, and you're just going to say, okay, so for number 3, you're going to say Sample is mine, I put copper, okay? And then 6th was lead. So 11.47 versus, ooh, that is not a 7. 11.47 versus 11.4. And this one was, I got 8.47 compared to 8.9, okay? So when you have these labeled, go ahead and label the top of those so that you don't mess up this next part. Your values are experimental. The ones that are in this table are your accepted values, okay? So label those for number 3. Number 4, you're going to actually calculate stuff. So you're going to calculate your percent error. That's something that we practiced in the warm-up yesterday and in the notes the day before. So remember, percent error is on your page. It says accepted minus experimental divided by accepted, and then multiply that value by 100. So when I do mine, okay, you only need to do it for your sample, by the way, okay? So my sample, I had 8.9 was my accepted minus my experimental, okay, all divided by my accepted. When I type that into the calculator, I get 0.048, and then I multiply that by 100 in order to get, or you can bump that decimal to the right, and I get 4.8% error. Okay, put a box around that answer. All right. Now what you're going to look for is number 5 says density can be calculated directly by dividing mass by volume. Use the mass and volume measurements and create a small table calculating the density of each sample. Okay, so you do not need to show your work for this part since you've already done it on the analysis page. If you want to, you may. But for number 5, what I want you to do is you're just going to go 1, 2, 3, 4, 5. And all you really need to have is density. If you would like to put mass and volume and then density, that's up to you. But I'm only requiring, so I'll say, or 1, 2, 3, 4, 5, and then you're just going to put density, okay? And you're just going to calculate it. Remember, you're just doing a mass divided by volume, mass divided by volume, mass divided by volume. At the bottom, I do want you to take the average. This average you will get by adding them all up and dividing them by 5. Okay, so the usual way to take an average. And what we're hoping to see is that it doesn't matter what the volume is of your object, you're going to see that the density remained the same. This right here is the fundamental idea that it is an intensive property. So right back from the pre-lab, this is an intensive property, okay? All right, so let me zoom back into this. Kind of messed up there. All right, and it says for number 6, write a brief formal conclusion stating whether or not this experiment supports the purpose or objective of the lab. That's in your opinion, okay? Use your data in your conclusion, including but not limited to all calculated derived values and percent error potential errors. And then, most importantly, I need to see this answer. What 2 variables were extensive in this lab, and which property was intensive? And actually, if you can come up with 2 intensives. I had thought of another one later on today. So that is it. That is what I'm expecting from you. You should be able to get it finished before I'm back. The very latest, you may turn it in Monday, but I would really prefer it Friday, no later than the end of the day on Friday. There's going to be a survey that you're going to answer so that I know that you got it done. And then we'll turn it in picture-wise on Monday, okay? Except for my AP students, you guys are going to be sending me a picture by the end of the day on Friday, okay? All right, so that's it. Hopefully that helped, and message me with any issues.